So today we are seeing at how SolidWorks Simulation can help in streamlining the design cycle and design innovative products. Before we start, yes, Adrian has already introduced me. I am Kapil Gaitonde. I am based out here in Singapore and I am specializing in simulation products. I'm into design analysis for more than 15 years now, and I would say I still relish the new possibilities of improving the design using simulation. And this is what I would like to share today. So coming to today's topic, what we are saying as streamlining the design process or the development process. Most of us are familiar with this serial process of design and thereon moving to simulation and finally manufacturing. So what happens in this process? Typically, there is a design team who does the design. Thereon, it sends the design for validation, and there is one more team which does the specialized work of validation. So this is a kind of serial process, and it has its own benefits and I would say disadvantages. On the other hand, we at Dassault Systems SolidWorks are working towards streamlining this process, wherein the design and analysis would be done by the same designer, and we are creating appropriate tools for him to handle it on his own. Effectively, this should save time, cost, and on the other side, give more time for innovation, which is more important. So we are looking at this particular scenario wherein the designer and the analyst are working either, if we see it in the time domain, at the same time, or it is the same person who does both these things and can take design decisions confidently. So this is more of a broader level improvisation in the design process which we are looking at. Now, yes, we have many products, and today we are discussing on design validation or simulation. However, we are trying to implement this and have implemented successfully in almost most of the different domains that a designer or an engineer would require to design his product. It could be starting all the way from industrial or conceptual designing. It could be CAD, more manufacturing oriented modeling and designing. It could be data management. It could be simulation, which we are seeing today, and finally it could be some tools which are necessary for manufacturing. So this we are working across the portfolio and helping designers to get best out of it and take the right design decisions. Now let me take a step back and get this thing started in a different way. I believe most of us are familiar wherein in the past we had a design, a 3D CAD design which was created on the software. Thereon we built prototypes, directly prototypes, which went into testing. We checked if it worked, all good. If not, changes would be required. Obviously this was an expensive process and it had its own challenges. In due course of time, we have moved to a process wherein simulation has become part and parcel of design, wherein a design happens, a virtual prototype is built, not an actual prototype, a virtual prototype of the entire product is built. Finally, we get into simulation or test the virtual prototype online or on the software, and we have more flexibility of changing the design for improvement. So validation is a step that got added, reduce the number of I would say designs that needs to be actually prototyped and manufactured. So this reduced and helped in more creativity, or other way around, this is the serial process which I mentioned a few slides before. Now, as I mentioned, moving on, we are talking about one more step further, wherein this part of designing and simulation would happen together at the same time. And today my highlight is on this particular topic, and the best thing I believe would be to see it in the software. Yes, what we saw as of now was more on the slides and the process, but the best part is we see it physically on how it works in the software. Let me get this GoToMeeting bar on the other side so that I have more space on the left. Okay, here it is. So this is SolidWorks. A designer, I would say, has created a interesting support here. It probably could be based on his experience, and now he is aware on the locations where this support would be fixed. He is also aware on the forces that are coming on this particular setup. I'm not dwelling in detail on the logistics of how to create this simulation, but one basic fact which I would like to highlight today is something like this, wherein you can see we are in the CAD front end now. I would get a tip button down here which is called as a study, and a particular simulation setup is already created here. So front end remains the same, no importing, no exporting. You're just moving on to, I would say, a few extra buttons would get added for the requirement of simulation. So here it is, I have the simulation setup. The materials have been added down here. The restraints are, as I mentioned, it is being held at a certain location, so those are done. And the pressure, as I said, in this case is expecting 1000 psi load down here, that has been applied. And let me take this new study and trigger the solution. Okay, so this was a simple setup, simulation done, no big deal. I would say this is to a certain extent what many softwares might be able to do in the market, wherein we say the software is integrated into the CAD front end. So here it is, this is certain part of the simulation which I would like to highlight. No doubt, obviously he will see certain changes down here, not changes, certain problems down in the design. He sees at a certain location the stresses are high. Well, obviously he needs to improve. So now there are many thoughts which can come into picture here. I get back to the CAD front end. I click on this particular feature either through the feature tree down here, or it could be as simple as double clicking on the feature. At the moment you can see it has a dimension of 6 units. I increase it to 8 units. Accept it. I rebuild this setup so that everything is updated well. This is a nice parametric model, no feature errors. I could increase it comfortably. I can get back to the study, simulation study, update it, and solid. That is it. So you can see here I have the flexibility of changing the design. Immediately I can go to the simulation part and trigger the solution. I have the results. Fantastic. So you can see I need not go to a specialized simulation software, or I need not hand over the model to someone else, but as a designer myself I am doing all these things immediately. So this is how it looks. Definitely the stresses have improved or reduced, but I'm not concentrating too much on that fact, but my concentration is more on the integration part here. So let's see a few more interesting things, or the most important thing which I would like to highlight today. So under study, when I get into, I have something called as a trend tracker. I am going to select this particular tool down here. Okay, so you can see it is already created. Before explaining, I'll directly use this tool and then you will see the advantage of using this particular tool. Now I have changed the dimensions to 8 mm and I have triggered the solution here. I can set this particular result as the baseline or the initial line. Okay, so I have it. I have created this particular simple details. Let me solve this setup again. Okay, so the baseline results are frozen in the setup. Now I just need to do this, and as a designer I may be seeing the results. Let me check out the results. How do they look? Displacement, stresses, they are in the tune of 1.33. I am not happy with this result. I still want to play with the model. I get into the SolidWorks CAD part of it. I double click the entity. I double click again, change the value, and I am all set. Let me go back to the study, trigger the solution. Let's have a look at the stress. They have changed a bit. Location remains same and probably more scope for changing. Before I do that, let me have a feel of how I forgot how the results look at at the dimension of 6. So I go back, I do it again. So as a designer, I get new ideas on the design. I keep on changing the design and I keep on solving this setup till I think I have done the right change. So I keep on doing these updates, the changes and the solutions. This goes on for a few iterations, and probably let me about this. Okay, and probably after a few iterations, I have a interesting question on whether I have done the right change, whether I'm improving the design or it is actually getting worse. And obviously I may not be aware of that particular thought after I have done all these changes for almost half a day, and I am in a confused state on whether I'm improving the design or I'm not improving the design. Let me trigger the solution. Okay, interesting. So you can see the stresses are hovering around the same location. Definitely they have improved, but not to what you have done. But in the meanwhile, I have done many changes to this design. I have taken an easy part, but imagine you as designers, when you do these changes on the actual part, at a stage we may get lost. So let me, now I can highlight the use of this particular tool, the trend tracker. You can see it was silently sitting here behind and doing certain things for us. So when I click one particular result, displacement, here it is. Oops. Let me get the plot. Let me make it bigger. So here it is. Now after doing all these changes, I can see the variation of displacement with different iterations. Definitely at a particular iteration of 4, it has shot up, and now when I increase the dimension to 15 millimeters, it has dropped down. No doubt it is going to drop down. Probably this is a simple model and we might be able to estimate it, but imagine it from another perspective. As a designer, I may not be able to, or I may get lost after a few iterations on whether I am doing the right things or it is getting messed up. So here it is. This can give us an interesting perspective on how certain important parameters are moving when we are doing changes to the design. So now that I know whether I'm moving in the right direction or I have done some mistakes, the next change I do can be of more confidence and I can do a different kind of right change. It also comes up with a quick journal here. You can have a look at it in the form of more details, more organized way. So this could also be handy. There are options by which you can we can directly move to a certain iteration and check out what were the loads and boundary conditions, those kind of things. Okay, so this is one kind of important and useful integration that you saw, which will help in designing and analyzing together and taking the right decisions. Another important aspect here, so in this CAD front end itself, we have something called as sensors down here. You can create your own sensors and tell the software on what you want to monitor or what creates an alarm for you when something goes wrong. So what happens is these sensors need to be created. Now it could be a stress sensor down here. You can see it is showing you the value of stress. I keep on doing the changes. I can update the sensors. It will automatically update all these things, and I can see if my update has increased the mass, it has reduced the mass, or in which direction it is going. So this could be interesting utility. Again, an example of integration wherein a designer himself can keep a tab on important parameters, whether they are going in the right direction, whether the changes are happening in the right direction. So this is one, I would say these two are important highlights which I wanted to make today. Moving on, I would like to show you one more interesting aspect. This, like the first two were a certain way of doing integration. It could be further, like these were small changes. I am doing major changes to this setup. I want to get rid of few things and I'm creating a new configuration. If you guys are already using SolidWorks, you guys are comfortable with the fact that we can create configuration and what it is all about. So I create a configuration and I add a few features here. So I would say I have done a few relatively important and bigger changes to this setup. Now again, I have the same doubt. Is this worth it? Have I gone in the right direction? I have already created a setup with the previous configuration, but I don't have a simulation setup for this. So now the software permits you to create a copy of the old setup, I just need to select the right configuration and I am all set. You can see an entire new study is created, which can be used for simulation. Here it is. So I did a few major changes. You can see the way stresses are moving down here. This entity was over designed, so we could safely get a slot in there, and it appears stresses have smoothened a lot. The higher values have gone down, and it looks I would not say better, but in a different way. Now again, this is another interesting aspect. So you saw we can move from one configuration to another, seeing the setups. I can also create my studies linked to those configurations, okay, and I can solve them, update them. Also, one part was you saw graphs in Trend Tracker, whereas it could be a challenge to compare the results down here. So we offer tools like compare results. So I can compare, probably I want to see displacements this time. Okay, let me stick to stresses then. Okay, I'll have it here. So you can see I can easily compare how the stresses move when there was a fillet and not a fillet between two configurations. So this, I think, in itself is speaking how the integration is going to help and how deep it has gone to help a designer to take the right design decisions. Now in this aspect, yeah, we did many things manually down here. But what if I want to do a few more things and in an automated way? Then it could be this particular example which I thought of sharing. Yeah, again, a simple model. I'm not dwelling deep into the restraints, but you can see it is being held down here. A pressure is applied at the top. Again, it is a parametric model and a simple let me check if I'm the initial iteration. A simple static simulation is done down here. Okay, here it is. No big deal. We saw how the integration is. This is all good. But there is one more interesting thing which I would like to show here. So you already saw how manually you can do the changes based on the requirements and track them, understand them, decide if they are going in the right direction. But it could be also cases where you want to let the software do it for you and tell you the best design. So in this case, we have something called as an optimization module, wherein I can select the appropriate dimensions. Okay, so in this case, DV1 is this particular dimension. We are saying it can move anywhere from 10 to 25 millimeters. DV2 another dimension, and one more dimension. So we can decide which dimensions are flexible to be changed. We can tell the software to do those changes for us, edit it, and give it in the optimization module. Thereon, I can set certain constraints. I want to ensure that the maximum displacement is less than 0.21 millimeters. I want to ensure that the frequency is between certain hertz, that is 260 to 400 here, and stress should be below 300. Our entire intention is to reduce the volume or the weight of this entire geometry. So this is a kind of setup that I can create in simulation, and I can trigger the solution. So I run it. So you can see here it is changing the model dimensions, and the solutions are going on automatically. So there is an intelligent algorithm in there which will decide or will play with those three dimensions and give us a setup which is more appropriate as per the constraints given by us, as per the goals that we have set to the software. So here you go. In less than 2 minutes, I got an optimal design for this particular bracket. The initial design looked something like this, and it has come up with an optimal design which looks like this. So you saw all this could happen because of the integration with SolidWorks CAD and the parametric design of this entire setup. And it is not restricted to static analysis. It could be natural frequencies which can be optimized, or any of the other parameters. Let me go back. Looks nice, but obviously 21.96 is a tough one to manufacture. I can go back, double click, let me get a realistic dimension of 22. Probably I'll get this streamline to 10. Okay, let me rebuild this. So we have done these minor changes. I also want to ensure these minor changes are good enough or should not spoil the results. Let me solve this again after meshing it. So the solution is done. You can have a closer look of the stresses for the entire body, for the newly recommended dimensions. You can have a look at that. And here you go. So you started off with a design, you improvised it using the optimization module, you came up with the manufacturable dimensions or the right details, and you're all set. So this is the kind of integration that we have done, and this does not end here. Obviously you can take it to the next step, wherein you can create a drawing from this design. It's hidden back here. Okay, let me get it. Here it comes. So this tells you the level of integration that has happened, and how a designer, or if I put it this way, a designer can do simulation on his own and take the right decisions. So now you saw the integration between SolidWorks, that is FEA part of it, what we call as simulation, and the CAD. We have also done a similar integration with flow, computational fluid dynamics. It is also true for plastics, to simulate plastic parts, plastic injection molding, and finally motion, that is kinematic simulation. So this is a huge amount of integration. It is not a day's work. I can say almost a 10 years hard work, intelligence and processes have gone into this. This will help in a big way to design products in a effective, faster and more statistical or value oriented way. So in conclusion, I would like to highlight all this should help in improving the quality and performance. Obviously, because you can see it is all integrated, should save a lot of time, and finally cost, which is equally important. So this should help us design products faster, cheaper and definitely better.